So I thought I'd take a quick video here of something I do whenever I get new electronics in. Usually electronics that aren't with a brand that I'm familiar with. You know, Sony or Samsung or really well-known electronics. You can generally trust that they've been manufactured to some level of quality. They have big name brands behind them, and the manufacturers would not stay in business long if they manufactured really junky electronics. However, especially when you source electronics out of China like I do, when I get a lot of stuff that's not common here in the United States, it's a good example is this is a 24-volt power supply. It's actually the board that's contained in the kinds of power supplies that you find at 3D printers and industrial machines, and they're just these kind of rectangular power supplies that come down and break out to a set of terminal blocks. You know, you have your main voltages here, you know, live, neutral, ground, and then you have a set of 3 positive 24-volt rails and a set of 3 negative DC common ground rails. It's very similar to the, you can see the power supply that I have inside of my Mendel Max 2 3D printer. It's a 24-volt. I don't know if it's the same exact brand or not. But whenever I get these things, I really do enjoy taking them apart just to see how poorly they're made. I do this not just for the enjoyment of it, but because you can generally fix a lot of their crappy quality solder joints that are cold welded and not actually soldered properly, shorts inside of the joints, just weird stuff like that. One of the interesting things I found about this one, and I don't know if this is common or not, I don't know enough about power supply design, but this can't possibly be a normal thing. So this is an inductor, right? It's got a toroid core and it's wound, basically copper wire. It's an enamel coated, so it's not like bare copper, but they've cut one of the windings. You can see with these two pieces here. I don't know if they did that because they used a general purpose inductor for, say, their various voltage 12, 24-volt ones, and they needed a different size inductor, and so instead of actually properly winding or buying or sourcing a proper inductor, that guy's leaves too, they just cut some of the windings or a set of winding to get to the value that they want. It's not a big deal, but I don't like how these wires are just kind of hanging here. That screams cheap Chinese electronics. That's really what it does. Next thing is capacitors. Always look at your caps, right? These are your capacitors. Please get close here. You want tops that look like this, pretty much. Flat, that can be a little bowed inwards, but if they're puffed out, leaking, cracks, there's goo coming out, kind of look like corrosive battery junk, that's no good. That's a bad cap. Caps are very easy to replace. They're incredibly cheap. These capacitors are pennies a piece. And so you always check your caps because they're one of the most common components in electronics to fail or just be bad to begin with. Here are the 2 giant mains voltages caps. These are like 650 microfarad, 250 volt caps. This is a power supply that's intended to work with European or US voltages, or North America voltages of 110 or 220. Or 120, 240, depending on what numbers you want to use. So these are big reservoir caps used to store lots of energy and provide a smooth, stable voltage and power for the rest of the unit. The problem is this one looks fine, but then when I pop this open, the first thing I notice is this guy jiggles, and that's not good at all. So what I'm going to do is flip this over here and get close. That is the solder pads that this is on, and as you can see, they've broke free from the traces on the PCB. And that's not good at all. In fact, it's really hard for me to tell whether they've lifted and broke the trace in the pad or it's just the whole joint has come off. It looks like they've broken the trace entirely, which is not good. It won't prevent this from working, but basically you only have one of these reservoir caps. So capacitors are one of those things that, generally speaking, in most circuits, there's a lot of capacitors that are just there for reservoir or filtering, that if you were to take them out under normal conditions, you would never notice anything. But under various conditions, under different levels of noise or different power usage, those caps become very important. So you fire this thing up and it seemed like it would work, but then you put heavy load on it and you notice that you're having weird issues, and it would be because this reservoir cap is not connected. Luckily, it's not that hard to fix. So this whole trace here, this one big giant trace going across here, This is all one plane, and I'm going to assume by the size this is the positive voltage plane, and this guy here is the ground or negative voltage plane, just based on size. This is just huge. You don't have huge power planes usually. You have smaller power planes. I'll verify that when I look on the other side, but it's actually really easy to fix this. I'll just run a jumper wire from here to here and from here to here up on this nice piece of solder on this track, and it should work fine. Same here, I'll just run jumper wire to here, and then that'll fix this particular cap. I'll try and reflow it and get it down. I might even put some hot glue over here to keep it from actually just jiggling. I might put hot glue on the other side as well. That'll resolve that issue. Another thing you always want to look at with electronics is the solder job, and boy, the solder in this is atrocious. Look at that. I mean, I have never seen so much solder. I mean, that's a ridiculous amount of solder. There's also been a lot of handwork on this. Like, this was touched up after the fact. A long time ago I used to work in a solder assembly, and you can notice things that are touched up. Like, here's a good example. This here, there's all this like charred resin and stuff in here. That doesn't happen when you flow solder. This happened because somebody touched this joint up and did a really poor job of it. Likely they touched up these other joints and just used way too much solder. Some of this might just be excess from flow or wave soldering, but it's hard to tell. Just really that's just really crappy. I mean, look at that. That's awful. So I usually give this a once over. You look for holes. I don't see any pads that aren't fully soldered. See here, you can see some more touch-up work done. I think this is probably to get rid of shorts. So I'll go back over and verify that none of these things actually have shorts on them, or it looks like people have touched up. Here's a nice trace that didn't even get solder. It didn't get touched by the solder. I don't like these transformer things here. I don't know what the deal is, why they have these little triangle deals. It's got okay creepage here. It's not too bad, but yeah, that's what you get. This is a cheap power supply. You get these things on eBay, or actually I bought these off of Amazon, shipped and sold by Amazon to be exact, for I don't know, 30 bucks, maybe 25 bucks. So a little bit you get what you pay for, but I thought, because the terminal blocks usually don't have this nice little protective cover. I mean, this is kind of actually a little nice feature. You don't see this on these power supplies. They're usually just bare terminals, and you have to put something here to protect, because these screws are live voltages. And you drop a screw down in here, or a tool falls and touches across, and that's no good. So I was impressed that it came with this, but not so impressed with the insides. So anyway, my little short video has turned into a much longer video on the qualities of Chinese manufactured electronics. Thanks for watching.